Okay, in this video we're going to look at constructing a slope field. Now that we've studied a little bit about differential equations, this is just another technique for being able to see how the slope is formed and see how we can form the original equation just by looking at sort of the slope. And it's a concept that's kind of hard to grasp at first, but let's just take a look at how do we construct a slope field. Then we'll start looking at the curves a little bit more in detail. So basically this equation defines the slope at any given point, unless it's restricted somewhere in the domain, but here you don't have any denominators or square roots. So let's just take a look at what is this concept of slope fields. And I believe this was off of an AP test, and they want you to sketch a slope field based on this equation, this slope equation, dy over dx. So looking at the graph, we have -1, 0, and 1 for x, and then we need to look at 0, 1, 2, and 3 for y. So one way to do this might be to just simply make a little chart here, like a little T-chart perhaps, and we could do our x's up here. We could put a -1, a 0, and a 1, and we could put our y's over on this chart, go 0, 1, 2, and 3, and we can just simply plug in our numbers, and in this chart we could write down our slopes. Just one way to keep it organized. So this is my x's and this is my y's right here. So we keep it straight. Well, let's start with let's do the x's at -1. Well, if I put in a -1 for all x's and I square it, it's going to get a +1. So at this point, anytime I multiply whatever I find for y, it's going to be my answer for the slope, right? So for example, the first point, if we put -1 squared, and if we chose y to be 0, you'd have 0 minus 1. So you have a +1 times a -1, so we get a -1 right here. So let's go down the line here. Let's pick this y equals to 1. Still have x at -1. So 1 minus 1. We'll do a couple by hand until you get the drift of it, then we'll pick it up a little bit. So x is still -1. And then we have, this time we're using y equals 1. 1 minus 1 is 0. 0 times +1 is 0. Okay. So hopefully you can see that the only thing that's really affecting this is whatever the value of y is. So let's put in y is equal to 2. 2 minus 1 is 1. That -1 squared is still +1, so we have a slope of 1 at this point. And then when we go down to y is equal to 3, y is equal to 3, we've got 3 minus 1 is 2, and 2 times 1 is 2. So there's that. So let's go ahead and talk about how we actually draw these slope fields, and then we'll do the other couple columns here. And what we have here is a couple of different slopes. We have a value of -1 when we're at -1 and 0. So when we're right here at this very first dot right here, we have to have a slope of -1. So we're just going to make little tick marks that are shaped in the general direction of the slope. So that one we might call -1. When we have a 0 slope, of course, we're just going to make a little flat line to represent the 0 slope. And if we have a +1, it's going to be a positive slope. And so we're just going to make little tick marks like that. And of course, when the slope is equal to 2, it's going to be a little bit steeper than 1, something like this perhaps. So just make sure you make them long enough, but not too long where they start overlapping. So let's go ahead and do our first slope. We have a -1, so it would be in this general direction like so. And when we're at -1 for x and +1 for y, we have a 0 slope, so we have a flat line right about there. And when we're at -1, +2 for y, we have a slope of 1. It's this guy right here. And when we move up to y is equal to 3 and x is -1, it's a little bit steeper. So something like this. Okay, so now that you have your general shapes down, let's go ahead and take a look at filling out the next column. The next column is when x equals 0. So this one should be fairly quick. If x is equal to 0, you take 0 and square it, you're going to get 0. So no matter what you get in here for this y minus 1, the whole thing is going to be equal to 0. So we'll go ahead and fill that out with 0, 0, 0, and just draw our flat lines all the way across, even on the axis. And there we are. And there we are. Okay, one more left to do, and that's when x is always 1. So when x is always 1, that's very similar to when x was -1, right? Because we're still, the equation has x squared. So we have 1 squared, and then we have y minus 1. So we'll just do 1 just to prove it. When y is equal to 0, 0 minus 1, so +1 times -1 does equal -1. So this is going to be the same. Okay, let's go to the next one. So when you plug in 1 squared, and now when y is equal to 1, you have 1 minus 1. So you have 0 times 1, and it's equal to 0. So this column is going to match up identically with the -1 column over here. So instead of wasting any more time, let's just get right to it. Put a 1 there, put a 2 there. Alright, so now we just basically are going to have the same slope field that we had over on the -1 right here. So we had a -1 right here. We had a 0 right here. We had a +1 at y equals 2. And then we had a steeper +2 slope right here. Okay. So this is the general shape that the curve is going to sort of guide our original equation, which we haven't solved for yet. We'll do that in the next video. But let's take a look at part C just for a second. I know we're kind of going out of order here. Part C says find the particular solution. Find the particular solution if you have 0, 3 as a given initial quantity. So at 0, 3, we actually are going to have a point right here, right? And so the slope at that given point 0, 3 is going to be horizontal because it's the slope field told us 0. So try not to mess up your graph or anything, but in general what's happening is as you're drifting towards the right, it looks like the slope is going to start increasing, increasing, increasing. So perhaps it's going to remain flat, get a little bit bigger, and then whenever it's right here, it's going to sort of blow up on this side. And look what's happening as you move back towards the left. The slope fields start telling you what? Around this general area that you're decreasing pretty rapidly, and then you're starting to flatten out a little bit. So perhaps the graph might look like this. Of course, this is all just a guess at this point, an educated guess nonetheless. Starting to get negative, and then it's starting to flatten out at some point. So that's about all we can surmise from this, but that's generally what the reason you're building these slope fields. So let me erase this, and we'll stop the video for right now, and then I'll pick it up and continue solving this one.